All right, welcome to our weekly DevRev live stream where we learn a little bit more about what's happening behind the scenes with DevRev's platform. Today, I have the pleasure of introducing to you all Drumil Patel, who's been working on our telemetry stack. Welcome, Drumil.
Hello, hi Ahmed.
Hey, and where can we find you today? So we're pretty global, so you never know where people are. I'm at home right now, but where are you?
So actually, I'm at my hometown Vadodara. So it's
Okay.
like in India.
Okay, fantastic. So thanks everybody who's joined us and continues to join us week after week. As you already know, and I continue to mention, in each live stream, we do continue these conversations on Discord. So we'll put a link to our Discord server and would love to see you guys there. We can probably continue the conversation we have today as well. And for today, the conversation is going to center around our use of a few really interesting and emergent technologies in the way of telemetry. And we'll start with Fluentd. Drumil, tell me how Fluentd sort of changed the way we thought about collecting melts information, events, telemetry, traces, so on.
So we start with a very initial round of architectures which we were discussing in terms of like observability, right?
Okay.
So we started with observability, like how to exactly ingest data, right? And the one problem statement which is like the general is that people build observability architecture based on silos, right? So metrics data will eventually ride in Prometheus, right? The traces data will ride into like Jaeger and Elasticsearch. Logs data will eventually write in Elasticsearch. So our basically the search started to build an architecture which is kind of like a universal, right? Universal in terms of like we can have the same architecture for metrics, we can have the same architecture for traces, we can have the same architecture for probably logs. And in future, if OpenTelemetry supports profiles, we should have the same architecture. So idea was to make it universal and make it more kind of generic in nature. So people can read our architecture or DevRev shouldn't be like every new data model or every new OpenTelemetry signal, we need to prepare the whole again and again. So that was the idea here. Like we need to build a tech stack, which is like very, what do we say, generic and universal in nature. So and again, an observability data itself is very, what we say, high volume, right? You can have GBs, terabytes of data within coming in seconds, right? So the search came and we eventually find out that Fluentd is something which is like being used for logs for basically processing and buffering out and to basically decrease the stress on like Elasticsearch and services. But one important thing which we eventually figured out was now Fluentd supports this Parquet creations. And what that was the major unlocking piece for us, that it can create parquets. Like we can just create buffers, and rather than saving into things, we can just use Parquet format to save data. So we can save logs data, we can save metrics data, we can save traces data in just this normal Parquets just in Fluentd.
So let me stop you there and say, now that we understand that there's this relationship between using Fluentd as this universal log collector, and then of course this format, Parquet format, which we'll talk about. Is there something you can throw on the screen here so we can start to discuss this while taking a look at something?
Should we like demo the whole architecture, or is it?
Yeah, let's maybe just look at something, and then we can ask some questions, because I'm eager to hear more about the Parquet piece of it. But do you have anything you can show us just to kind of ground the conversation?
Yeah, sure. So I think is my screen visible?
Okay. So what are we looking at? It looks like we are inside the DevRev app right now in your browser. Yeah. Okay.
So one thing which we are basically discussing is like what we have as a support in DevRev app. So everything here is something which is directly supported by DevRev. So the idea was to view logs, right? So this particular dashboard is specifically for viewing logs for services. So we have all the services of DevRev, right? We have probably around 200, 300 plus services. Now people can search services based on this requirement, and then we have this logs dashboard. Like we can have the severity, trends, and everything, and we also have the logs of all the system.
Yeah, and I mean, of course, we've connected it here because we have sort of a native inbuilt dashboarding reporting mechanism, so we can grab this information and present it. But before it could even be presented, obviously, talk a little more about that format that you talked about, Parquet. I know it's a highly compressible columnar format, but what's the big unlock? You talked about how log forwarding, then getting it into a Parquet format really enabled this. Say more about that.
So one major aspects of Parquet is that so it's like a CSV format, but it's more of oriented for columnar, right? So and when we just talk about observability data, it's always redundant in nature. So for example, you have thousands of log line of similar kind of space, right? So so we have thousands of log lines. You have thousands of log lines similar to just a single attribute, right? So what happens is that we can have a major compression ratios when we have columnar based compressions, right? And what we eventually found out with Parquet is that we have the based on this kind of columnar based compressions have same attributes. There is run length encoding across all the attributes, which basically decreases and have a very good compression ratios. And again, the third piece, which is like the universal compute DuckDB, eventually works great with Parquet. Again, we will talk it later in this same podcast. But the idea here is due to the repetitive nature of observability data and due to the like run length encoding possibilities of that data, we use Parquet. And I think in the same demo, I can show that how compression ratios affect the observability data, like over standard JSON over the Parquet data. If we can show, I can show that.
Yeah, please.
So this is the data which we have, right? And is my cursor screen visible, right?
Yeah, we can see it. So you're in cursor right now.
Yeah. And what we found out that, for example, we have all the data right now in Parquet formats and the JSON format, the standard data format, which is storing the data. So we have logs, metrics, and traces, right?
Sure.
So if we see logs, right, and you just do this do mnsh command, you will eventually find out that same JSON and same Parquet have a different file size. So it's like 620K for JSON file, and it's like 108K for the log file. And what we see is like around one fifth of the standard size, like 1/6 of the standard size in the Parquet.
Yeah,
so this is
over. Yeah, it's like 85% compression.
Yep.
Yeah,
so
fantastic.
That was the idea.
Okay, and so that's helping you. That's going to help you actually be able to transport the information, because you're going to transform and store a lot less data after the log aggregation is done.
Yep.
Okay. What else? What do you want to show us?
So that was the initial idea, why exactly Parquet is and what happens. And one of the possibilities with Parquet is that it is very it is analytic. It is majorly built for analytics use cases. So for example, when we do this severity trend based querying, right?
Yeah.
We don't have to scan through the bodies and all the attributes. We can just scan through the status info, right? And eventually find out that what are the info tags and that. So this makes that particular query on this status info make very fast, right? So the idea of using Parquet is and basically have just a single column to be scanned for a particular query, make it way useful.
Yeah, I got a question here from Mahendra. It says, so metrics and logs and traces are all grepd, or is it only logs?
grepd in terms of...
Okay. I think he might be just saying grept. Yeah, are all grept, or is it only logs?
So for logs, we do grep based architecture, graph based querying, but for metrics, it would be more of like fingerprints and metrics, and it would be like a long SQL query. Again, I will explain in the prompt SQL and type. And for traces, it is like you have a trace ID and you have to do a graph. So that would be like a filter query.
Okay, Mahendra, you can always message us on Discord as well, and we can get into the details. It was a little hard to parse the exact question, but go on, Dramil.
Yeah. So this was the idea for the logs type of things. We also have metrics. So I can explain the metric side of things as well here. Okay. So give me a minute. Okay. So again, we have some multiple dashboards. So we have dashboard support for metrics, right? And what we eventually have is like we can using the our dashboard framework support, we can now eventually query PromQL, And using that PromQL query, we can just basically render the dashboard. So this is a very standard dashboard, which basically our security team build on. Like we use OPA. OPA is like Open Policy Agent. So we basically monitor that P95, and this kind of metrics are emitted, and we need to build a dashboard over it. So we edited in DevRev app, we can eventually create this dashboard, again powered by custom dashboards, and which we have right now. And I can explain you more in like what goes under the hood. So probably that would answer the question.
Okay. Now the question is going to be, I mean, why don't you go ahead and show what you're showing here? But my question is going to be, how is the information being served in this widget? Like, where is it coming from? Is it coming from some sort of remote service, or is it coming from some kind of a local cache? Where is it?
So again, so the architecture side of things is probably I can show the diagram more. That would eventually be helpful here. So the idea here is we have everything in Fluentd. Fluentd buffer out and create parquets stored into S3. And now we have a DuckDB layer for that remote querying capability.
Can you put it in slideshow mode so we can all see it a little better?
Yeah, makes sense.
Thanks.
Yep. So the idea here is like we have Fluentd, right? And the hotel is basically ingesting data into Fluentd. And as we discussed that it is a universal writer kind of stuff, And what we are doing is based on this data, we are buffering it out and we are creating a parquets and then basically dumping them into S3 warehouse. And the main
reader what kind of partitioning, like when you talk about creating parquets, what kind of logic are you using? Are you blindly just creating parquet files every few minutes? Are you doing it based on some sort of partitioning technique, some kind of a filter based on a certain pattern? What is it? Are you doing one per pod? Like, can you describe that a little?
So it depends on the like the requirements or the query patterns which we are supporting, right? So for logs, it's mostly like you have given a service and you have to get the logs for it. So there we use service-based partitioning and we have time-based partitioning. So as observability data is time-driven data, everything is like time-derived data, right? So we can partition by time, and we have another parameter for the partitions, which is like services for logs. For metrics, it is more generic in nature, and it can have like multiple metrics. So what we did was we did shard, but rather than sharding by like a specific metric name, we group the metric name and have like a maximum of 100 shards and then split the data across the shards.
Got it. Okay, fair enough. Oh, keep going.
So the architecture, which is like Fluentd, basically have this partition information, and every 10 minutes, it basically flush them into the S3 warehouse, right? And what we as a read interface do is basically we have a DuckDB component that, again, DuckDB is something which we'll discuss it later, but it's more of like this component which can operate anywhere, right? It can operate in web. It can also operate in servers. It can, using web wasm, we can run on the web. It can work onto our local systems. It can eventually also work on Lambdas. So the idea was to have this DuckDB component querying this Parquet files. And again, as we discussed that we already, like we were always building a universal architecture. So we have like Fluentd as universal writers, Parquet file as a universal data format, or like how we transfer data. The DuckDB support as a universal read compute, which is like using that to query. And we have the SQL layer, which is majorly helping us to execute that query in DuckDB on that Parquet files.
That makes a lot of sense. I like what you just said about the run anywhere or operate anywhere attribute of DuckDB. So coming back to the example, you were getting into your browser inspect, and you were showing us something, and I think what you were trying to show was how we were actually running compute on that data, which is coming from DuckDB. Is that correct?
Yes.
Okay, so let's have a look at that.
So what exactly under the hood is going on is whenever we do a query or something, for example, let's do a very basic query here, like a very simple query. So now under the hood, the DuckDB wasm is getting hit.
So people can see, I mean, you typed in PyCamel, which happens to be a service that we are running. So you're just doing a service name based query. Is that correct?
No, it's more of like we have that body as an attribute. So it's like a like operation on the body. So every PyCamel based thing would be used here. So I can just change it to streaming and you will get the data. Okay. So here is streaming. then you get all the streaming things of data. So it's just searching on the data. So it's more of like a grep on that data.
Okay, got it. You're just doing a keyword search here.
Yeah. So again, we have like multiple attributes. We can use that attributes to do a query here. And this was the like UI. And if you see that, what we are internally hitting is this DuckDB wasm component, which is like executing that query on our Parquet file. So if you want to go on the Parquet files, we can just go it. So
is it possible to just kind of zoom in on that section of your browser?
Okay, sure. I think is it visible, right?
Yeah, it's really good.
Okay. So if you see here, what we have is like probably Oasis as we selected Oasis here, we have Oasis as a service here. If you see, so this consists of all the Parquet files which we have, and so internally what happens is basically we are saving everything into the local memory of this particular Parquet, like log_Oasis Parquet, and the DuckDB is operating on this particular Parquet file. So this is a byte data which is getting saved, and we are querying on this data.
And where is DuckDB running in this particular case?
This is running in the browser using wasm.
Okay, so we have a WebAssembly module where DuckDB is running locally, and what DuckDB could have been running remotely, but in this particular case, it's running here. And so what we've done is we've effectively transported those Parquet files that were generated after the log aggregation. We've taken those Parquet files, we've actually transported them, loaded them into DuckDB, and that happens to be running in a WebAssembly module here. And I'm able to access that information effectively at the edge on my machine and do database queries effectively using SQL.
Exactly.
And that's pretty awesome because this is all being rendered from local data.
Exactly. So one advantage we see is that whenever we have a very low frequency query, we don't because one observability module is that we have like a single compute layer which is like hitting every query. So rather than moving that, we have that local web can do that same query for us. So what this unlocks is that we can serve more people, more users into the system without affecting like the noisy labor problems which happens when the multiple people are executing the same query, because every query is now operating on their system rather than a server-side, computer-side kind of architecture.
Yeah, wonderful. What else do you want to show me?
Yeah, so this is like a log set of things, and we also have like the metric set of things, right? So I think so what we have right now is probably we can explain more. So I think I'm zoomed in much. Thank you. So when we treat about metrics, so metrics is not exactly what we say a grab-based module, but even it is more of what we say kind of like a SQL or analytic query which is going on. So DuckDB will actually help us with that kind of flow as well. So if I can just do a refresh and get the latest data. So if you see that lots of things which is under the hood going on.
Yeah, so you're showing us network activity. Maybe you can point out a couple of things. It's a pretty small, slim sidebar, so a little hard to tell, but you want to point out a couple of things here?
Yeah, sure. So one of them is like every widget you are seeing is a PromQL separate query. So for example, this is like a P95 query. This is more of like what are exactly evaluations going on, how much is allowed, how much was denied, right? So everyone has a different PromQL query. So if we just get a preview here, so the payload was give me the histogram quantile of 0.95, and this is my Prometheus, what we say, metric. This is the metric name. This is my what we say attributes, and this is like the give me P95 out of it. So under the hood, what is going on is basically we have this PromQL query. We are converting them into a SQL query. So if you see the response here, and this is the SQL query which is getting executed on the DuckDB and which is able to generate this data out of it.
And how is that transformation happening?
So what I think this is like Nandan and Ilan helped us with this, and what exactly that they do is basically we have the PromQL query, right? This PromQL query. And it is basically whenever there is a PromQL parser which is basically provided by Prometheus. what it does is it breaks that AST into different set of things, right? So it can consist of that there is some group by logic we need to execute, there is some computation logic we need to execute, there is some filter logic getting executed. So we break down that AST and then parse that AST into a SQL query. So this includes like filter getting and then getting that querying and then executing that query. So this is the idea here, that we break the PromQL AST, and using that PromQL AST, we can eventually go up the flow and create each AST based queries and each node, and then basically create a summarized SQL query, which is eventually getting executed on.
Okay, we'll have to have them on for a live stream just to explain that part. But I mean, so far what I've understood is the following. Big breakthrough from your perspective, Fluentd as this modern cloud native, cloud foundation, approved aggregator. And the big unlock for you was, why don't I use this as a generic aggregator across the board, i.e. a universal aggregator? And that was the first sort of observation that you guys made. Number two, what you said was, listen, the way to really kind of make sure that this is going to work for us is to have a highly compressible universal format, Parquet. We started to have that. And of course, you have to have a mechanism to be able to persist those Parquet files, distribute them in an authorized, authenticated way, right? So you can give people offset-based access to Parquet files, based on tenancy, services, or whatever else you're doing. And then once that information can be transported over to wherever it needs to go, you need a place where that information gets loaded and can serve as your universal compute layer. And what you love about DuckDB is the fact that not only is it a very good engine to actually run and power these widgets, but the great thing about it is that you can run it remotely. You can run it in a sort of a localized way. Here in this particular case, you're running it in a localized way by running it in a WebAssembly module, which then sort of allows you to communicate directly within your local machine with the reporting and dashboarding layer. And the reporting and dashboarding layer is basically showing a graphical representation of some queries that you're writing, and there's some transformations happening there. So you can describe what you want to see. It knows how to build SQL out of that. It knows which actual files to access that information from, or what tables to access that information from. And so you've got everything from going and getting service level logs into a system to being able to define arbitrary widgets that can allow you to see the information from a dashboard like this.
Yes.
Yeah. Awesome. And you, of course, you also showed us sort of an arbitrary, free-form text-based searching mechanism as well.
Yes.
Yeah. Awesome. What else do we want to see here? We probably have time to see one or two more things.
So one thing which we basically also shine for us, probably we are not able to mention it, but one thing was like the OpenTelemetry.
Yeah, you might not. Sorry to interrupt, but can you put it in slideshow so it's a little bigger?
Oh, yeah, sure. So one thing which basically was one of the most deal breaker for us was to be compatible with OpenTelemetry, because what we see was that there was an initial problem where the client was emitting something different, but agents was emitting something different, and probably that there was no common language for integrating the open observability data, right? So what we started one of the deal breakers which we got was like OpenTelemetry, like compatibility with OpenTelemetry, because OpenTelemetry has a big ecosystems on like what it is supporting. So using this particular ecosystem, what we did was we didn't compile to every kind of format, but we just compiled to we were just compatible to the OpenTelemetry. So what happened was that we now have all the support for hotel SDKs. We have hotel support for Kubernetes pods, like all the attributes and everything. So we ingest metrics, data, and logs, and traces logs and everything in observability format. So now we have agents, like agents. There is an like OpenTelemetry agent 6, which is basically dealing with this data. So idea was that being OpenTelemetry compatible will help us to basically ingest every kind of observability data, whether it's from customers, whether it's from Kubernetes pods, or whether it's from third-party services like Fastly and everything.
And remember that. Thank you for sharing that. And I know that you're just from a scale perspective and really starting to use this to perhaps start to expand the number of services within our own stack that are actually sharing information or publishing information through this mechanism that you've been working on. how far along are we? Are we using this for several services now?
So yeah, so what we are doing here is we have onboarded multiple services into our systems, and what it also helped is that we have also already onboarded the client-based observability into our system as well. So some of the client-based systems like desktop apps and everything are started to onboard into this platform so that they can ingest data from the client side as well. And we have also onboarded agents observability, so probably that can be a good talk as well, and how agent observability helps us to basically visualize the agent based trails as well. So this is under development and probably would be soon ingesting the data into our systems.
Okay, so in the next several months, you're going to learn a lot about what's working, what's not working, tuning the system, and then it sounds like you probably want to have most of our service level logs go through this mechanism as well once you've validated everything. So this is a very exciting moment for you guys. I'm very excited about this project, where it's headed. Technology wise, it just seems like we're jumping on a lot of really interesting trends right now. Thanks to if anybody's watching and contributing to any of these technologies that we talked about, whether it's OTel, whether it's Fluentd, whether it's DuckDB, or any other technology that we've been talking about, we'd love to hear from you. The charts that we showed, those are built based on top of high charts, which is also a pretty popular library out there. So any high charts users, we'd love to hear from you guys as well. Join us on Discord. So I think a part of what we like to do here with these live streams is to be pretty open about what it is that we're using behind the scenes to actually do the things that we're doing. And part of architecture is being able to design systems that can actually work well together. So couple minutes left. Is there anything else that you'd like to discuss with us, Dramil? Thank you so much for your time.
Yeah, everything's fine for us.
Okay, fantastic. So folks, again, appreciate your time. You guys got to see, sort of how we connect the dots between services, clients, providing disparate sources and different types of data, but it can all sort of universally be aggregated, ingested, swim laned into highly compressible formats, stored in the cloud, accessible through normal sort of authentication and authorization. That then goes into a universal compute layer. We use DuckDB in that case, and then of course that DuckDB can be queried. You can query it ad hoc. You can also query it in a formulaic way, which is backed by SQL. But then of course the front could be a graphical interface. Like in this particular case, we use high charts to create reports and dashboards, and it all works under the hood using the same technologies. And it scales really well. And in this particular case, it was actually running on the user's device. So Dramil was actually able to do analytics on logs from multiple services that were running on his device and were being periodically updated. So is there a way to get this to be even more real time? I know it's not in real time. No telemetry system is really real time, but how close do we get here?
So we are working on a architecture where we will basically get 10 seconds of delay rather than the expected delay of 10 minutes. Because again, there's a DuckDB component. You can go and float DuckDB somewhere into the Fluentd clusters as well, and then able to render it out. So there's something which we are doing experiment. We are learning more on this one, and probably in future months, we will eventually find out that we can eventually move it to 1 second or something as well.
Okay, so you're trying to go from 10 minutes to 10 seconds, and maybe we can have you back here in November to talk about that.
Sure.
Okay, sounds good. Well, thank you, Dramil. Thanks for joining us from your hometown, and folks on the call here, appreciate your time. And wherever you are, please join us, talk to us. This is probably going to get posted on YouTube as well, and so we'd love to hear from you on the comment section there, if not on the Discord server. So again, we'll see you next week. Thank you so much for your time. Take care. Bye.